We have been talking about so far about the transitions of electrons among different electronic levels. So uh, we've been talking about how electrons can move from one orbit to another. From now on we will call that orbitals, but from one orbit to another, and how that implies an absorption or emission of a photon of light. But it's important to understand also that the same way that electrons are quantized in orbits, any other energy level that a molecule has is also quantized in specific levels. So, and it's important to go back to the to to the electromagnetic spectrum to realize that depending on the frequency of light that you use, you can activate or deactivate some specific energy levels of molecules, not only electrons. And this is important in medicine, for example, because depending on the wavelength of light that you use, you can look at specific aspects of that molecule. Let me give you an example. So the CT scan and the X-ray, what they do, they carry enough energy, the photons of X-rays carry enough energy to move electrons of heavy atoms, and typically from inner core electrons. So like calcium, I believe it's a 4s or 5s, so it has a 1s electron down there. To move that electron upward, that takes a lot of energy, and this is why X-ray, you can see the calcium or the iodine in the spectrum, because with that much energy you can move electrons among levels that imply a lot of energy. It's not a coincidence that the human eye can actually see the transitions on the most fun, if you will, electrons on the valence shell, the one that show reactivity. So that's while it's a tiny range of frequencies, that's what the visible light implies. It's small jumps on the valence electrons. Okay, but it's not only electrons. For example, vibration, as you probably know from infrared spectroscopy, vibration of molecules is also quantized. This means that if this is one electronic level and this is another electronic level, each of the electronic levels have, if you will, tiny vibrational energy levels. And how can you go from one to another? You can do that through infrared light, with the frequency belonging to the infrared light. Okay, so that's tinier. The difference in energy among the vibrating levels is smaller than the electronic levels. And not only that, even the rotation of molecule. Apparently a molecule cannot rotate at any speed. It has specific given energy levels, and those are called rotational levels. Okay, and those rotational levels are the ones that are being, for example, activated in a microwave oven. Notice that the microwave oven typically targets the frequency of the rotation of water. If your sample in the oven does not have water, it will probably not warm up, because it's not able to rotate the molecules or whatever that is not water. Okay, but there's not even another level, and probably you're also familiar with that one. Through radio waves, what we can do is to move among nuclear spin levels. So probably you learned in your organic chemistry that the nuclear magnetic resonance technique, what it does is moving your sample, or in this case the atom, from one level of the nuclear spin into another level of nuclear spin. So the take-home message is that we can use light to excite different energy levels, not only electrons but also vibration and rotation and the nuclear spin, and all that long range of energy levels has a long range at the same time of applications.